She runs a research lab.
So we're missing... Well, what's that?
She teaches at a university.
They're not plated down on these.
And she's co-founder of a nanotechnologies company.
So what we're looking for is feedback from you.
Living by the wisdom of Yoda, biomedical engineer Michelle Kine is all about embracing life.
The problems that we work on, these are important problems. There is a possibility that we can really make a huge impact on people's lives. That's a great motivator.
Biomedical engineers like Michelle combine biology, medicine, and engineering to design and develop new equipment and methods that improve the quality of human health and life. They design everything from surgical devices, prosthetics, and artificial organs, to systems for medical imaging, patient monitoring, and diagnosing disease. They also develop new medical procedures and research solutions to clinical problems.
I get to teach and work with students and work at a university. And I also get to have a company on the side and work with industry, so I feel like it's the best of all worlds. Yeah, it works really well, and I'm looking forward to getting this into the hands of students and researchers.
Michelle has pioneered advancements in manufacturing medical diagnostic chips, a new technology that miniaturizes lab testing. Initially, the chips, which have microscopic grooves for moving samples like blood through a series of lab tests, required expensive equipment and took a long time to make. Remembering her favorite childhood craft, Michelle got a crazy idea.
So I was playing, as I usually do, in my kitchen one night, and I realized that if I took Shrinky-Dinks and I patterned onto the Shrinky-Dinks, when they shrink down, I could use the features on the Shrinky-Dinks to create my microfluidic chips. So these are pre-stressed thermoplastic sheets. So you can imagine it's sort of like a rubber band that's stretched out and then frozen down, right? So when you heat them up, the polymer chains relax and they go back to their relaxed state, so they shrink back. To be perfectly honest, it was really hard in the beginning. I came up with this idea and we published, I tried to convince my students to use a children's toy for their science. And they were like, people are gonna laugh at us.
But people didn't laugh. The invention went viral on the internet and catapulted Michelle into the spotlight. Scientists from all over the world were now interested in Michelle's lab on a chip.
If I treat one patient, I can treat that patient. But if you come up with a medical invention, a technology that can save hundreds or thousands of lives at once, that's, that would be really cool. So this small size here is 1.5 microns. The width of your human hair is about 150 microns. So this is about 1/100th the width of your hair. So they have the EVs, and then how do they apply the different chemicals?
Michelle and her research team have also been working on ways to grow embryonic stem cells into heart muscle cells.
Once we create these cardiomyocytes, we need to figure out how to maturate them so that they're functional heart cells. A day in the life of me. I usually play soccer with my dog in the morning, and then I walk to work. I come in and I work with the students, and we work on coming up with new crazy ideas and writing papers and working on grants. I have a company on the side, so I work with a company also. We're trying to commercialize our first 2 products this year. Hey Mark, ready to meet?
Good. Yeah.
Different metal, different structures on the metal.
As scientific founder and a member of Shrink Nanotechnology's Scientific Advisory Board, Michelle helps research and develop new biomedical technologies and products.
Very exciting, very exciting.
She also looks at ways to improve and expand the benefits of existing product lines.
Titanium.
I like to tell people that I make accessories. I'm still a girl. A big part of my lab is focused on developing point-of-care diagnostic devices. Our goal is to be able to bring really inexpensive plastic chips to the developing world so that we can detect and then therefore treat infectious diseases early on. We're meeting with the chair of the pediatrics department at the medical school here, because he's very interested in bringing these technologies to the real world.
And so if we can even have a screening test that can be done at the bedside.
It's a neat job because you don't checking in the morning with somebody you don't check out, right? You decide what problems are important to you, you work on those problems, and you police yourself.
Like many engineers, Michelle tends to think about her work 24/7, so she stresses the importance of balance in her life.
I love to play. I also discovered a new sport called acro yoga, which is basically two-person yoga, and you can do, flips and aerials, and it's really fun. I used to be big into biking. We built a human-powered vehicle when I was at Berkeley.
In fact, Michelle holds a land speed world record for a bike she helped design and build in grad school.
Being able to really have the conviction to carry it through to the end, knowing that it might not work, is very difficult. But I think I'm an optimist at heart, and so that kind of keeps me going. Feels like a cooking show.
Michelle holds a Bachelor of Science and Master of Science degree in Mechanical Engineering and a PhD in Bioengineering.
I decided to become an engineer because I was really bad at math and science. And I thought that if I studied hard enough and I worked on it enough, that I'd get good at it. So I did a summer internship in biomedical engineering when I was 15, and I loved it. It's hands-on, it's real world. You feel like you're making a difference. You're not solving problems that other people have solved before. These are brand new problems that people need answers to, and that's cool.
Biomedical engineers work in hospitals, universities, industry, and laboratories. They work with physical scientists and engineers, clinicians, life scientists, chemists, and medical scientists.
I think biomedical engineering is extremely collaborative, and I think that's what I love best about it. What is that?
No.
Have you ever seen that deposited on metals before?
Let's see, for that scale, no.
It's this culture of working together and talking with each other and coming up with new ideas and forming these collaborations, even if they're on the other side of the world. Your world feels very close. You don't feel isolated at all. It's been a great ride. It's far exceeded any expectation or dream I could have ever had. It's been really fun. I've gotten to go give talks at really cool places, Vancouver, Hong Kong, the Caribbean. I was invited to MIT for the TR35 award, which was really exciting for me. It's been amazing. I was real fortunate to have gone into biomedical engineering. I can't imagine a better job in the world. See? You never believe me.